Welcome to this presentation of SlimCD's EMV Link product, and this presentation is designed specifically for developers. In this presentation, we're going to be showing you the EMV Link product and how it makes access to a pin pad extremely simple and completely removes you from PCI scope, because it takes the pin pad and places it on the SlimCD network. A little information about our company. We're going to cover quite a few topics here today, so I'm going to move rather quickly and let me get started. So EMV Link is a small box that's placed on the merchant's network. You plug an Ethernet cable into the box, and then you plug a pin pad into the box, and that places the Ingenico or Verifone pin pad on the SlimCD network instead of on the merchant's network. Therefore, to access the pin pad, you simply make a call to the payment gateway the same way you might if you were doing direct API calls with card numbers. Instead, you don't give it a card number. Instead, you give it the address of the VPN box, and the VPN box will light up, the EMV Link box will light up the pin pad and run all of the transaction for you, returning approved or declined. So as I mentioned, the box is quite small. It's 2 inches by 2 inches, and it's standard USB powered. And you just plug in the WAN port, the Ethernet, the LAN port with a TCP/IP pin pad, Verifone and Ingenico, and it'll turn green and you're up and running. It is completely semi-integrated, which means you don't need any EMV certifications. And here's an amazing thing: the merchant can now fill out an SAQ-B form, not a C or a D, but a B, which is a very simple form of the PCI form. Great advantage for this product. So here's an example of a 915 from Verifone and an IPP 320 and an ISC 250. All of these are supported. Now what's interesting is we're using standard firmware from Verifone on the Verifone and standard RBA firmware from Ingenico. So these are not custom builds. This is standard firmware from the manufacturer running on these devices. And the only difference in a call to run one versus the other is you simply say Ingenico or Verifone. All of these devices are going to do encryption in the hardware layer and send all the data up encrypted to SlimCD. And of course, since the EMV Link is actually a VPN, it's actually doubly encrypted by the VPN communications as well. Every transaction will return a token to you that you can use for refunds, voids, or even charge cards, again, cards on file, and you can use that to pull down the signatures that were captured by the pin pad or print receipts, etc. If you want to know more about the encryption and tokenization, we've got some videos on the website. Check out our direct APIs and our acquiring tokens videos. A lot of information there available for you. So there are two implementation approaches. There's a synchronous approach where you would change the timeout parameter on an HTTP post to this web service, because the pin pad is going to be interacting with the merchant. So you'd send a very long HTTP post timeout request calling process transaction, and you'd wait for it to respond. The other option is an asynchronous transaction where you send a request and it returns to you with an ID, and then you simply poll calling check transaction status, so that way you can display status dialog box on the screen and give the consumer or the clerk a chance to cancel the transaction from the point of sale system, and we do support a cancel transaction in that event as well. So when you post these web services, you simply use XML or JSON. Actually, I have a test URL in there instead of a live URL, so forgive me for that. It's not even formatted correctly with a single slash. I'll take care of that and fix this slideshow. It accepts XML or JSON, and the XML or JSON that you create has three separate objects in it: a connect object, which identifies which device to connect to, and then the standard, which is very similar to the standard SlimCD connect object for regular .NET pin pad libraries. If you've watched that video, you can see that the connect object there takes either a COM port or it takes an IP. In this case, it also takes a VPN address. So the connect object takes the VPN address, the name of the VPN device, the endpoint, and it lights up that pin pad. The CFG and request objects are very similar to what you've seen in the other ones. Matter of fact, I think they're identical in these cases. So you can turn on and off different features, on and off credit, on and off debit, on and off signature capture. We'll go over that here in a minute. And if you send XML, you get back XML. If you send JSON, you get back JSON. So here's a connect request. In this case, you're simply providing the VPN ID and the VPN username and password, and you're giving the DLL class, in this case Ingenicos, and Ingenicos were run on port 12,000. If this was Verifone, you put port 9001, and that's all you do to connect to the device. This is the standard configuration object, turning on and off different options, whatever you'd like. And the standard transaction request where you can put in the credentials for the merchant. And again, I suggest using API access credentials here instead of usernames and passwords. Check out the video on API access credentials to learn more about how they work. And you have a lot of options here. You obviously don't have to fill these in. As a matter of fact, if you don't put them in, we'll default them to blank for you. You can see there's very little information. Give us the amount. If you have industry-specific data like auto rental or hotel, you can add that information in as well. Here's an example of a JSON reply that you get back. It's going to give you the gate ID, which is your token. See the video on tokens. You're going to get back the approved status. You're going to get the type of card, first 6 and last 4. If we can give them back to you, certainly you'll get the last 4 in all cases. The expiration date, month and year, the approved amounts, whether or not it was keyed, whether it was PIN debit, tip amount if you're supporting tip prompts, cashback if you're supporting cashback prompts, etc. So here are all 3 objects together, followed by the reply. So it's these 3 objects wrapped in a JSON structure, getting back the reply. In XML, here's the same thing, the connect request, the configuration request, transaction request, followed by the reply. Now, you can format up your own XML or JSON, or we do have libraries written in .NET and Android that allow you to process these same transaction web service calls without actually having to do the HTTP post yourself. In those cases, it is a library that exposes properties. You set the properties for the username, the password, etc., and you invoke a method and you get back a response. And we have an exerciser tool that lets you test this stuff out in all those languages as well. In addition, you can launch our native application in Windows, our SlimCD for PC that supports this. So you launch our app and it's pre-configured to use either the VPN or a local pin pad, however the SlimCD for PC has been configured, and you can use the EMV link VPN that way as well. Now, one of the things the VPN can do for you is give you a little bit of a device management where you have ability to say, for this VPN ID, give me return a list of all the VPNs available for that particular merchant, and then for a VPN ID, what are the pin pads attached to it, so you don't have to store that locally. You can simply pull our cloud-based configuration system. You can store it locally and do it yourself, but alternatively, if you'd like to get take advantage of our cloud-based configuration, then the merchant can log into our website and turn on or off features like whether or not they want credit or debit or gift, and your software just retrieves their settings, sends it down to the device. So it works either way, but these are some real handy features, so you don't have to store and control the configuration, simply retrieve it from our web services. You can even test connectivity, reset a device, reboot a device, etc. We will in the future have some ability to download CAPKs and AIDs and things like that. Those are specific EMV configurations for a specific device, maybe turn on and off American Express, that type thing. So we've actually integrated the EMV link into our own product. You can use it from within our own virtual terminal on our website. You can use it from a hosted payment pages and from SlimCD for PC. So the implications of this is that these devices can, any pin pad that's connected to an EMV link device can be used by anything that can do an internet connection, a website, a cloud-based system, an Internet of Things device, a Raspberry Pi, whatever you want could run one of these as long as it can perform an HTTP post. So just about anything with internet connectivity has the ability to do that. Makes it very powerful, yet folks can still use those devices with the applications that we provide that come with our services. So if you only want to implement sales in your application and have them do refunds through our website, certainly that's possible. When you do EMV transactions, there is a lot of information that can come back in the way of tags. It's available to do research. You do not have to use this, but all this is available for troubleshooting. Why transactions don't get approved, for the most part, this is up to us to do, but I wanted to show you that that information is available. And you'll notice over in the middle there's a receipt, and it's got a block of information in a different font. When you call the get EMV receipt data, you can get back either XML or plain text. I recommend getting plain text, and you'd merge that into the receipt that you're printing if you're printing your own receipts. And that way you have all these hex values that you need to be Visa and MasterCard compliant. If you want to get the images for the signatures, if they're using a signature capture device, you can ask for them in a variety of formats. Or if you want to get the raw data back in the Verifone or Ingenico native format, you can do that as well. Alright, so let's take a moment here and let's demo everything I've talked about to show you how this works. I'm going to start by showing you some of our own products. So as I mentioned, in Slim CD, I can log in and I can run a VPN pin pad transaction. So I actually have two VPNs set up here. These are their VPN IDs, but those are awful long numbers to configure, so you can actually set up aliases and call them by alias as well. Actually, there's 3 VPNs here. This one's inactive. So the merchant has the ability to go into an individual one, assign different pin pads to it. You can do some health checks in here, and you can certainly configure one. So if I'm going to configure this Verifone, here are all the EMV flags I talked about being available from the web, so your web services can call these things and run them. And the merchant can also come over to the VPN pin pad, select the pin pad to use, and run transactions on there. So to show you how that works, let's bring up a camera. See, I can align these windows so you can take a look at what's happening in real time here. And again, this is our website. This could just easily be your point of sale, your cloud-based solution, or anything you want. So I'm going to make up a number of $46. And when I click on EMV swipe transaction, you'll notice the pin pad lights up over here and it starts the transaction. So right away, that starts a transaction, and our website can completely control this, and we can prompt through all of this information. I'm going to cancel the transaction out here, and website as well. So notification did come back to the website. So let's do it again, and this time we'll run a full transaction. And I will take my EMV card, insert it in the reader, and in this case it got a decline because it only supports test cards, and it went all the way to the processor and the transaction was not allowed. So on that test account I can't use this real card. But that gives you the idea that it would have prompted me for the rest of the information, including signature capture. So that's an example of using the product within our website. It's performing the same web service calls that the developer can do, and I have a sample program that uses our library for .NET. So let's take a look at that. So first thing I'd like to do is I'd like to come over to Web Manage Configuration, because I want to take advantage of the fact that all of the settings are stored up on Slim CD. And here's the test account I was using, and I'm going to execute the web service call to get the VPN IDs and the pin pads. And I get a list of the IDs and a list of the pin pads that are attached to each one, and here are the settings that are configured for that particular pin pad on our website. So I now have a choice of doing a synchronous transaction that's shown here, and if I execute the synchronous transaction, it's simply calling the process transaction, and in this case I'm going to take another card, which will also get a decline on this system, but I'm going to swipe it. This does not have a chip. Card read error. Let's see if we can do that again. Please wait. Prompts are happening. Confirm. And again, it was declined because I don't have the same thing, auth trans not allowed. It's not the actual test cards for this test host. But that gives you the idea of how the transactions work. Now let's take a look at asynchronous. Again, it's pre-filling in all of the checkboxes that it got from the web service, but I can override them. So I'm going to turn off signature and turn off total prompts. And I'm going to call the asynchronous version. Actually, let me cancel that. Oh yes, that is the one I wanted. So let me call that one, because this one has a callback. So if I'm showing the screen over here, it is now telling me insert or swipe, which matches the screen over here. So I'll take my card, I will insert it, and it now tells me it's going out for processing. Remove the card, and it was declined, and I'll get the declined answer over here, the same auth not allowed, telling me the name on my card, the transaction ID, the last 4 digits, etc. So the asynchronous allows me to poll up top with a callback, getting the information. Again, this is built into our .NET library, but the same thing can be done with web service calls, and then the final result is shown here that this was declined. So we've talked a lot about these web service calls. Let's see if we can take a look at them. Oh, one more thing before we do that. Let's show you the same functionality built into a SlimCD hosted payment page. Now, hosted payment pages allow you to type or swipe the card number, enter the expiration date. If on the hosted payment page you put information that identifies the VPN ID you want to use, username, password, etc. And again, I recommend using API access credentials, and obviously you wouldn't make these editable on an end user form. You'd hide these, and these would be database only, and check out our hosted payment page information to see how to do that. But here's also your configuration options of what you're entering and overriding. When you have these elements on the form, you'll get a transfer to pin pad button, and choosing transfer to pin pad lights up the pin pad, and here we go again. In this case, we're going to do the $20. And I'll swipe this card. Credit or debit. And I'm going to cancel the transaction because we know that card's not going to get an approval anyway. If it were going to get an approval, I'd have signature capture and everything else. But because this is declined, now I'm being told within the hosted payment page. So all these methods, including hosted payment pages, are available to you to use and get access through the EMV link, which shows that cloud-based and web-based and point-of-sale applications can very easily run these devices through simple web service calls. So now let's take a look at some of the web service calls. Let me find our URL for that. I'm going to go to our developers download page, and under VPN resources we have the integration reference. So in the integration reference, it brings up a Google Docs that gives you all the information about these web service calls. And since these are simple web service calls, this data here that you're seeing can be formatted as XML, or it can be formatted as JSON. In this case, you're seeing both JSON and XML. Here are the endpoints to test connections, to reset the device, to reboot the device, etc. So they're very simple web service calls. And if you call process transaction, you want to set the timeout pretty high. I would even go higher than this, because people can chat at checkout time, you know, deciding who's going to pay and look for their card, etc. So you want to give this a nice long timeout. If instead you use the process transaction async, it's going to return right away, and it's going to give you an ID that you'd call in a polling fashion. You'd call the check status to find out when it's finished. Now notice you can also do keyed transactions, which uses the pin pad of the device so that the cardholder can type in their card number, and that's supported both on the Verifone and Genico devices. So you can process synchronous or asynchronous, regular EMV or swipe or insert, or you can process a keyed transaction if you like, where same connection object, the prompts are a little bit different. The object for configuration objects are a little different. Do you want to prompt for address and CVV2, etc., things you do on a keyed transaction, and then the same transaction object, and you get the same type of results. And of course, you can cancel a transaction and check the status if you're using the async model. So this document is available with all the information in it. It's simple web service calls. You can also follow this document to, there's also custom forms available. So if you want to display your own forms on the screen, just like you can do with our DLLs, you can display custom forms to ask them if they want to sign up for your loyalty program or whatever type prompts you want to do. and that's all available here too. Custom forms and getting back the answers for them, process fields, etc. And of course there's the web managed config that let you, here's an example of that, lets you get the IDs for a particular client and then lets you get the pin pads, etc. So that's a quick overview of the VPN. And again, cloud-based pauses, this is perfect for. Websites that want to run pin pads, or even mobile applications. Take a store that has one pin pad and all the cashiers are walking around with tablets. You can take the customer over to the pin pad, and whoever's got the tablet can fire up the EMV link connection and run the transaction, and when they step away, the next cashier can walk over and use that same pin pad. So you can share a pin pad very easily with this EMV link solution. Very powerful, and the PCI reduction is extremely valuable. So I've shown you the sample that we have for it, the .NET exerciser. I've also shown you the direct web service calls and, of course, the hosted payment pages. So check out our developer's website and the direct API calls you can do with the tokens and all the other videos that talk all about that. And again, your downloads under VPN resources will have the .NET sample plus the documentation I've shown you. Please take a look at all of that. And thank you very much for watching this presentation of the Slim CD developers functionality.